not to mention other pressures, and lack of sleep probably. And maybe too much caffeine and or too much Smash Brothers. So that's a small test. At the end of the day, at the end of the semester, I make an assessment that is much more general one. And I think adjustments and so forth to a grading scale make much more sense on the semester grade than they do on the test grade. So I'm going to talk about how that's going to work first. But as a result, I have not done what I've done in some of the previous years. I'm just giving you the score because I looked over the scores and I think they're about the score. So. I looked at it and I'm like, oh, okay, overall. And I'm like, well, I look at an average paper, and like someone who's near the mean, and I look at it and I'm like, yeah, that's not right score. So, that being said, the scores are low. This is not so uncommon. That's to say it's every year. That's fine. Right? It's not common, but I want you to be prepared for it. I want you to try to overcome the urge to react emotionally, because this is not actually an emotional decision. The fact is the grades in the class are low. I will shortly tell you how we're going to deal with that, because these grades are not going to go to the gradebook right away. Not before you have something else. Okay? I'll explain that in a moment, but I want you to not freak out. I want you to think about, okay, what can I do better? I want us to think about this. Think about this with our brains and our hearts right now, okay? Because I think that is a better solution. And I can tell you this for sure: whatever your grade was, you have plenty of company. You were not. You might, even if you were technically the lowest grade of the class, which someone has to be. There was someone else who was right next to you. So, just letting you know that it's not like that big a deal. Okay, so. Sitting computers, yeah. Okay, so mean was 67. Okay. So
I want to die. I don't have the money to buy a rope right now.
Around 10, right around 10.
The shower curtain.
No, I can't. How?
You know it's impossible.
Do you know? No, but the material the shower curtain is made of is going to swell before it gets to where it needs to
I think that will appear in Power School. I will shortly tell you how we're going to deal with that. But first, let's just get this part over.
We're going to cheat the system and add 700 points. Your grade's going to be fine.
No, it's not. I didn't care.
The score is written on the front of your test.
What's that front?
What's the front again?
62.
Out of what?
100.
That guy's the class. He probably got.
If he got a 62.
I want to die.
No, I didn't. Because there's no way I beat you.
You could have. I didn't study for the test.
I spent the entire Wednesday and most of the time Tuesday studying for this.
I studied with you too, so whatever you get, I'm going to get half of that.
You didn't study with me.
For like during lunch or dinner or something.
Oh yeah, that's true. You did study with me.
Is this out of 100, the grade?
The final score is out of 100.
Okay.
Each one individually is not. Each.
I want to do
Oh, God.
Stop celebrating your happiness. We're all depressed.
Where's the youth?
We're supposed to be unified in our sadness and hatred. I think you got it done before you do that.
What was it?
real bad. Oh my god, I'm survivor. No, I'm not.
You're not ever going to be okay? Listen to me, guys. This is a big deal. I promise. I swear on my existence.
I have a couple of knives in my room.
You don't understand this one.
No. You got a better grade than me.
I highly doubt that.
Is yours above 20? Is yours above 20?
Yes.
Is yours above 40?
Okay, sorry. First, I need to explain the grading system.
Yeah.
The grading system is Has been developed carefully over the course of many years. It's weird and obtuse, but it gives the grades that I want. So, and it's fast. So I grade them with numbers that are not percentages or points. You may notice that they do not add up to the slides. Okay? The numbers are just the easiest way for me to indicate how you did on the problem. I have much more fine gradation than I do on the quiz. So it's a 7-point scale. And 0, you only get a few left the problem blank. If a few people did it, please make sure next time to leave a few times to draw a squirrel or to write the letter A or something. So that leaves points. The 7 is perfect. 6 means you missed something very, very minor. Perhaps you left out an unimportant minus sign or maybe a unit mistake or something. 5 is a more common, a minor mistake. Like you basically got it right, you got one small detail. 4 is a more substantial mistake, which could still be a minus sign, and some of those minus signs are really important, right? If you're doing a time dilation and you got you multiplied it the wrong way, for example, that might be a 4. 3 is you had the general idea, but that's a pretty big mistake, a pretty big missing. 2 means like, okay, you were doing the right subject, but it really wasn't the right path at all. And 1 means at least you wrote something. Okay. So these correspond to percentages like so. Okay. So they're not a straight scale. In particular, a 5 is not a 5 out of 7. It's a much better percentage than that, right? So you can get an idea of how it is. This is just the easiest way for me to grade that I can come up with so far. And putting them all together is something that Excel does for me. So I don't have to worry about the math errors. If you have any, so it's like that in every problem individually. And so if you have any questions about anything about scoring and stuff, I'm happy to go into detail, but let's not do it right now. Let us talk about this. Sorry it's been so long, but I'm hoping that the trauma that has burned it into your memory. With length casting the rod, the key point is to get the full credit on it. What I really needed you to mention is that when this end of the rod moves, the other end of the rod cannot move at the same time. There has to be some kind of signal or something, some kind of effect that travels to that end of the rod that moves at the speed of light. That's one thing I have to mention. The other thing I have to mention is that the result of the rod cannot remain rigid because there are no rigid objects in relativity. And therefore the rod will bend. Of course real rods do anyway, but this will bend a lot more when you're casting it. And so you'll get a bend in it. And the third thing you needed to mention to get all the credit is that therefore the other end of it, because of the bend, will trail along behind and it will not be able to, it will still not exceed the speed of light. You do need to mention that part, it's important, right? So that last part should not, the last thing will trail the speed of light. It will not exceed the speed of light. That's what I was asking you, right? And it will bend. And of course, the rod might possibly break, and that's fine too. But the important part is to emphasize that it's a signal that has to travel, right? And that the rod will not stay rigid, but will bend. And then there will be a speed of light delay. Okay. 2011. Number 2, in 2011, this is the real thing. It's about the opera fast online neutrinos. There are different ways to do this one. Most people's arguments were mathematical arguments, which are okay. I gave you like part of the credit. I think I gave you 4s and 5s of those, depending on how well you explain it. Remember, 4s and 5. 4 is not 50%, right? 4 is 75%. It's not bad. And 5 is a B, basically. Okay. I did say specifically it has to be a physical result. And the thing is, you say, oh, I can't switch to the reference frame. They give you, oh, who cares if you can't switch to the reference frame? That's not really a physical result. That's the problem. Okay. The real problems that are physical, right, not just mathematical, have to do with the paradoxes, right? Most of the paradox problems, actually all of them, except maybe the twin paradox, I'm not sure, but most of them rely on the fact that nothing can go faster than light. The easiest one for this is the train bomb paradox, right? You have the bomb at the front and the thing at the back, and you get the two things, and you're like, oh no, 2 different axes and 2 different reference frames, it's a paradox. But then the whole thing is saved because there has to be some kind of signal, and the signal has to go slower than light. And if you allow that signal to go faster than light, you just broke the whole reason for the whole solution to the paradox. And now you actually have logically inconsistent results in two different reference frames, right? And so that was the main thing I was looking for. If you didn't get the full credit, it was probably because the description wasn't sufficiently clear. As always, I do my best to grade fairly on these, but I think I can. Okay, so those were the first two. All right, number 3 is a question of how fast he has to throw it in his reference frame. So his velocity is root 3 over 2. That's his velocity. That's the velocity of Sonic's reference frame. And the speed that he throws in the Earth's reference frame is negative root 3 over 2, right? And so in Sonic's reference frame, it'd be this. Right, which gives you on the top negative root 3, and on the bottom 1 plus 3 over 4. So that gives you negative root 3 over 7 fourths, or negative 4 root 3 over 7. See, with your velocity. Okay? People generally did pretty well with that. You might have gotten the signs confused. The main thing is, if he has to reverse the entire velocity of this thing, and I asked, I actually, it was a little ambiguous about it, so I didn't care about the sign. He just put positive sign. But the main thing is, he has to reverse the direction of it. How hard is he going to have to throw it? Very, very hard, right? In his reference frame, though, you should expect, where it's starting off still, you should expect it to end up going very fast in that reference frame. So you should expect a number very close to 1, which is what this number is. So that works. If you get the sign wrong, you get a number much smaller. Okay. What does this look like? I was glad to see that some people got this, because this is a tricky one. Because it's still the same relativity paradoxes, but this is a version of it we haven't actually seen before. So while it's possible to figure it out, it does require some insight. And here's the trick. On the other hand, I was kind of surprised. I was kind of hoping more people would get at least the general idea. This problem is primarily, it's so much like the pole vaulter problem, right? Because he's standing at the back of it, and there's a pole coming out, right? So he's here, and here's the pole, right? That's the issue. So the pole vaulter problem was all about what? Signals traveling back and forth down the pole, right? It was always about things traveling. So in particular, when he throws the pole, which part of the pole does he throw? He can only throw the back end of the pole. It cannot instantly affect the front end of the pole, right? And so what actually happens, the front end of the pole will have to keep moving. And so if you're on this side of the wall watching, what do you see? You see the back end sticking out this way and the front end sticking out that way. Briefly. Then eventually the signal makes it down to the front end, and if it's a very elastic key, it'll bounce back and catch up this way, and then the whole thing will fly off to the left. Or if it's or it'll break or explode, right? But whatever it is, that can't happen right away. At first, the front of the key is going to keep on moving, especially if it's going to this velocity. And then whatever effect is caused will take over, and it'll stretch or break or bounce or whatever it will do. Okay, so that was the key part I was looking for. Like I said, it's tricky. We haven't seen that effect before. It's almost like a length dilation. It's not really, right? It's just two parts that cannot affect each other at the same time. It's not rigid objects.
So would it, right?
I mean, it depends on what the key is made of. I mean, it's going for root 3 over 7. This is not actually a realistic situation. So I'm not going to give you a realistic answer.
So what if you answered with a realistic answer?
I think by now you still have my question for me.
You should give a relativistic answer.
Number 4. Number 4 is a rough page. It's a difficult page with a lot of difficult problems.
Yeah, I noticed.
Okay. The first one, so in the Earth's reference frame, you have ash and rock, right? And ash, if you assume ash's throwing is at the origin, which is a very sensible thing to do, most people assume that, which is very sensible, then rock throws it 1 second later, and 3 light seconds, being sloppy with my units because c equals 1, it all works out anyway. Okay, so we have this. So for the first part, it's actually all we need to do is calculate the space-time interval s squared, which in this case would be if c equals 1, then it would be 1 minus 3 squared, or negative 8. You get s squared less than 1, then you get an answer of negative 1 is a space-like interval. A space-like interval, what does that mean? The order can change, right? And so that was that question. That was what you needed to do there. Now, a few people got messed up with the units because like, oh, you have to put c squared in there. That's okay if you want to do that, but if you put the c squared t squared, then you have to make sure this is in light seconds. So it also is a factor of c, right? And so it still comes out to negative 8 as your answer. Negative 8 plus light seconds squared.
Wait.
Okay. So a few people got messed up with that. I understood where you're going, but yeah, that's just something to watch out for. Okay, now part B. Okay, part B is a tough problem. Statistically, it is the toughest problem on the test. That is to say, that is the one that people had the most trouble with by the numbers. It's a tricky problem. The reason it's tricky is partly because I realized I actually haven't given a problem like this before. I'm not completely sure why not. Like I wasn't like deliberate, but I haven't given a problem that was of this form because this is a problem that actually has 3 events in it. Not 2. Most of the problems don't have 2 events. So it's 3 events. Ash grows, rock grows, and the Pokeballs collide. Right? So we can actually figure that out from the fact that they move it. You can figure that out in the Earth's reference frame pretty easily by the fact that they move at 0.6c. So ashes, after 1 second, ashes will travel 0.6 light seconds. Right? That's going at 0.6c. Then that's when rock grows. Right? So then the remainder of the time, you have it, so this is 3 apart, this is the total amount of 2.4, right? You split that in half, of course, because they're both the same velocity, the Earth's reference, the same speed in the Earth's reference frame, right? So this is 1.2 here and 1.2 here. So the x-coordinate is, right, so the x-coordinate is going to be right here, 1.8. The time coordinate, so the x-coordinate has to be 1.8. The time coordinate you can get from the fact that it goes 1.8 and it's going at a speed of 0.6c. So the time coordinate has to be 3. So part of the tricky part was that a lot of people didn't even realize you needed to calculate this, that you could. And that's realization that's important. So there's a third space-time form vector, which is 3. 1.8 is 9 over 5. 0, 0. Okay? Then you have to transform this to an unknown reference frame, Misty's reference frame, which is unknown. Yeah, did I do a good job with the, if I had to load all the stuff up, the Pokemon's after my time. But Misty's a character, Onyx is the fast one, right?
Deoxys is the one you wrote, and Deoxys is the fastest.
Deoxys, not Onyx, yeah, Deoxys is the fastest. Yeah, there we go. So, I looked it up in Bulbapedia. Find anything you want about Pokemon. You can't find things about like actual important stuff, but Pokemon, no problem.
Actually,
so you have to take both of these, well, all 3 of these, the origin is easy, right? And you have to transform both of them to figure out this problem, which is a bit of an extra jump, right? So you have this one. So this one transforms with an unknown gamma factor, right? We don't know what the velocity is. So this one. I'm going to focus on the x-coordinates for right now, and you'll see why, because that's the problem's asking. X becomes gamma, 3 minus b, right? This one, the x-coordinate transforms to gamma times 9/5 minus 3b. The reason I only need to focus on this is because what it tells you is that it collides, and sorry, I'm not wild about the wording. If I get this problem again, I'm going to change the wording to make it clear. But I think but listen, what I saw on the test, we basically clarified that it was we're looking at a spatial difference, right? So we're looking at a position being halfway between. So that means if I call this x prime 2 and this x prime 1, what we basically mean is x prime 1 times 2 is the x prime 2. It's halfway between, and one of them is the origin. Right, so this is the equation. 2 gamma 9/5 minus 3b equals gamma 3 minus b. Here, if you had set it up, if you had not set it up right, then you could get into a lot of algebra, as some of you probably noticed. And I hope some of you made the right decision. I saw some people write up, okay, can't get any farther, moving on. I saw some people writing that was the right thing to do. If you get tangled up in the algebra, it's better to move on. Especially because you might have to do something wrong. Because if you set it up like this, you can see what happens. Gammas cancel. No square roots to deal with, right? And suddenly it's actually a very straightforward problem. This is 18 over 5 minus 6b equals 3 minus b. So if we move this over here, we get 5b equals 18 over 5 minus 3. 3 is 15 over 5. So that is 3 over 5. Therefore, b equals 3 over 25.
That's a lot. So
it's actually not very much math, but it's tricky to get all those steps in order. And I understand that. And don't worry, we have a solution, but I will talk about that in a moment. When I finish over the Okay, so I know this one's at 0. The origin never changes, right? And then x2 is rock throw, right? And I know that the ball is positionally halfway between them. So that means the ball's position coordinate is half of Brock's position coordinate. That's the best I can do that. All right, part C. Part C really was a fairly straightforward problem. The math got a little messy, the algebra got a little messy, but like you should have been able to set this one up.
This one's I can
I will actually no one actually got the exact answer.
And that's
This
Part C.
yeah.
I mean,
This one would have been
there needs to be the box for that. So we're going to do this takes some flexibility.
For part C.
Right? You were right, I remember that. It was at one look and I'm like, oh, I guess it is.
And then I'm like, okay, this can't be right. I must be doing something wrong. I went back. Because I poured that. I'm like,
Because you know that the mass of the Pokeball is 40 and that their velocity is 0.6, right? You can get the energy is going to be 40, I'll do this fast, times 5 over 4, which is 50. And the momentum of the Pokeball, well, in the Earth's reference frame, of course, will be at 50 times 3/5, which is 30. Right? It comes out particularly easy. Both of them are the same except they're in opposite direction. In the Earth's reference frame, these guys are really easy to write. One looks like this, and one looks like this. Now, for the remainder, about after they come out, you are given information in which reference frame? You could choose reference frame. So, so if this is Pokeball 1 and Pokeball 2, then you have Pikachu. Then he's at rest. Pikachu's at rest, and he has an unknown mass, but no velocity, which is at rest. And then Jigglypuff, it tells you a mass of 30 and a velocity of 0.8. So again, it's a straightforward calculation. Again, I'll do it extra fast, but it works out pretty nicely. And a momentum of 50 times 5 over 4, which is 125 over 2, and you don't even need to use that, it turns out. Okay, so here's your 4 vector. If you wrote this, I think that was a 5. Oh no, sorry, you couldn't just write this. You had to show you actually knew what to do with the 4 vectors, right? But if you got this part and then just started to show me the basic parts of the problem and couldn't finish it, that was a 5, that's a B at 85%, right? And if you got a decent way into it, then that was up to a 6. If you got up to if you could simplify through the math, like up to the penultimate step, that was a 6. Like, there are points here that could have been gotten, but this part really wasn't that hard. We should have been able to do it. I think probably all the other stuff going on was probably confusing and maybe time pressure was cutting into things. And that's okay, I understand. So what we have here now is, of course, now Pokeball 1 plus Pokeball 2 squared equals Pikachu plus Jigglypuff squared. And so that gives you the mass of the Pokeball squared, right, plus 2 times the inner product, plus the mass of the other Pokeball squared, the mass of Pikachu squared, which actually had the capital N, plus the 2 times the inner product, plus the mass of Jigglypuff squared. And we have all these numbers, we can plug them in, right? The mass of the Pokeball is 40, so 1600 is 40 squared, plus 2 times the inner product of these is 50 times 50, so 2500, minus, but then there's a minus sign here, so it becomes plus 900, plus another 1600 here. And over here you have n squared plus 2 times inner product of these gives you 50m minus, multiply those, you get 0. And then Jigglypuff's mass is 30, so 30 squared is 900. From this point, it's just some simple arithmetic, right? We can go real fast here. 3,400, so 3,400 times 2 is 7,800, so this is 3,200 plus 7,800, or 10,000, no, 11,000.
Wait, is it 34 doubled 6,800?
Yes. Thank you. Which gives you 10,000?
Yeah, I got 10,000.
Okay. Equals, oh yeah, 10,000, totally 10,000, yeah. Plus 100 and plus 900. So if you got up to, okay, if you want to simplify this slightly, you can get this. And getting up to here was a 6, right, 95%. And people in trouble with this last step, what do you do? With the formula. What about a formula?
Isn't it
If you can't factor it in like a few seconds, you should go through that formula.
Be a minus depending on that.
Yes. Thank you. Good job. And so, square 100 squared minus 4ac. 4 times 9100 is 28,400 over 2. And this is negative 100 plus or minus the square root of 38,400. Is that right?
It's 300. It's 364.
I'm not sure. Wait, let's try this again. 36. Yeah, okay. See, that was wrong. Thank you. There you go. Much better. And you should reduce the radical. It's actually very easy to reduce this radical. There's a factor of 100 here, so you can get 10. And then this clearly is divisible by 4. So you get a factor of 2 out of that. And so what's left behind is 1, 6. Is that divisible by 4? It is, isn't it? Okay, so we can simplify that. So negative 100 plus or minus, so 20 times another factor of 2. And divide the 4 into that gives you 29. That's literally not factorable. This cancels out, and you end up with 20 root 29 minus 50 dV, or what's the mass? Sorry, kilograms. Yeah, we didn't do this on dV. That is the exact number. If you're not taking that class, that's exact. Everything else is approximate.
What's the approximate?
Hold on, root 29 is somewhere between 5 and 6, right? Use a calculator.
Wait, what is the?
That's 20 root 29 minus 50.
It's about 57.7.
And now, the giant disembodied head of William Howard Taft.
Oh, yeah.
I used to go to the Taft. Oh, yeah.
I forgot who.
You ever seen the giant disembodied head there?
Oh,
Good. So, for part A,
I think he might be.
Part A is very much like something we preached before, and that is the one trick of it is you have to make sure you're doing time dilation on a time, not on a rate. So one laser per second has to be inverted. Of course, that's no problem. That means 1 second per laser, right?
Yeah.
That's a time. 1 second is a time. You have a gamma factor of 5/4, and so you are, and the proper time is going to be in Taft's frame. The Taft's frame he's not moving, so the lasers will all be fired in the same place. So if that's the proper time, you are going to have 5/4 seconds per laser in your time. Therefore, 4/5 lasers per second. Okay. So some people missed the last one. A few people got the time dilation backwards, but okay. For part B, it is not the same thing. You probably realize that it couldn't be the same thing, right? But of course, the tricky part is why not? The reason why not is because Taft is moving. So, he fires a laser in your reference frame, right? This laser moves, this laser is going the speed of light, but it's a laser, right? And it takes 5/4 of a second between each laser, right? So in your reference frame, this laser moves 5/4 light seconds, right? Before he fires the next laser. But in that time, Taft has also moved because he's going 0.6c, right? So in that time, he's gone 3/5 times 5/4 light seconds, which is 3/4 of a light second. So the distance between the two lasers in your reference frame is actually only half a light second, because he moves in between when he fires them. And so, since there's only half a light second between them, if they're coming steadily half a light second apart, right, and they're moving at the speed of light, then you can figure out the rate, how many times per second will you get hit? 2 lasers per second. They're coming steadily, they're moving at the speed of light, right, so you get half a second per laser, therefore 2 lasers. So this, some of you will recognize that this is a Doppler effect argument, and there is in fact a relativistic Doppler effect that works, just like this. But this basic step of it is something you can do with simple math. All right. All right, the nodes lasers. So these problems were about your understanding of energy momentum. They're not easy problems, I understand that, right? But they're about your understanding of energy momentum. So you are starting in Taft's reference frame, right? So here's Taft's giant disembodied head. And here is you, and which way are you moving? It's Taft's reference frame, he's stationary, you are moving towards him. Right? So first of all, I think some people didn't get the picture. I mean, it's Taft's reference frame, this is what it looks like. And of course the lasers are still firing. Okay? So he is actually slowing you down with the lasers. Right? The laser is applying momentum to you backwards, which slows you down until you stop. Make sense? All right, now, your initial energy, so your initial energy is, you have initial mass, but you're moving. You have a velocity of 0.6c because, of course, it's going to be symmetrical, right? And so your initial energy is your mass, is your mass, which is 100 times the 0.6c gamma factor, which is always 5/4, and that gives you 125. And your initial momentum is the energy times your initial velocity, which is 75. Okay? So a good number of people got here, and I'm glad. That was the right thing to do. And if you missed it, I understand these things. There's a lot of stuff to deal with, especially when you're giant floating heads of former presidents and chief justices on your paper. He was after he finished being president, he was then made chief justice, only person ever to serve both. And also the bathtub thing. That's what everyone always knows, the bathtub thing. Okay, now it's actually a very easy problem. Which one of these, we're trying to stop you, which means which one of these is going to 0? Momentum. Momentum is going to 0. So, how many nose lasers does it take? 75, 5 joules per laser, 25 nose lasers.
Wait, 15.
15 nose lasers.
I'm like,
oh my god.
Sorry, I forgot to sleep either.
You can't.
I mean, you made 25 though.
You know what? What's your score on this? Yeah,
No, you. What did you do?
5 minutes. 5 minutes.
I gave off because I couldn't
Momentum
see
by
it.
energy of each laser. So,
I didn't calculate
sorry, that's a good
that
question.
frame.
Vinay's right. I didn't explain this one. Each laser has an energy of 5. But because it's a laser, its momentum will be
5
also, right? So each laser is giving you a momentum of 5, or if you like -5, it's reducing your momentum by 5. That's why you just count how many lasers it takes to give you 70 times. Sorry, okay, what will your mass be at the end of the bombardment? If I can figure it out, I will try to give you points for being consistent. That's very straightforward. Your mass energy has to be conserved, and at the end of the day, you stopped, right? And At the end of the environment, you are stopped in this reference frame. So you have 125 that you started with, plus 15 millilasers, 5 joules each, right? Gives you 200.
You can't find momentum.
Yep. That's that part can be done with simple conservation of energy, especially because we know you're stopped at the end of the day. So all the energy had to go somewhere. You're not moving, so it's not
You can avoid this rule. Because you get over zero and determine versus
So what is
in your own reference frame,
is just equal to
in your own reference frame,
minus b squared equals m squared.
the rectangle originally you're oppressed. You are here, and the lasers are hitting you. Now it's different. Here your initial energy is 100, your initial momentum is 0. Right? And now, each time a nose laser hits you, it will increase your energy and momentum by 5. Right? So each nose laser will increment your energy and momentum by 5. You need to get up to a speed of 0.6c. Well, how do we find the speed of an object in terms of energy and momentum? P over D. So what we want is P over D eventually. These are the initial. We want the P over D to become 3/5, right? 0.6. So you're going, if you're hit by n lasers, you're going to have a momentum of 5 times n and an energy of 100 plus 5 times n. And that will equal 3/5. Solve for n, and you'll get 300 plus 15n equals 25n, so 10n equals 300, or n equals 30 lasers. Yes?
So I guess like I did it a different way and got something wrong, but like I don't know what's wrong with it.
You got 3, that is different.
Yeah.
You did a transformation.
Yeah.
You did a transformation. I asked how many 5 joule nose lasers in that reference frame. You don't need to do a transformation. But what you did was it affected things here. I gave you actually more points. You got that.
you did.
Because
So volume
it was a sensible thing to do, but it was a misunderstanding.
Volume
So,
is the same. How does the
part F,
increase with the
you guys really should know the word reconcile, by the way. It's not that
The
advanced.
perimeter
I'm just saying.
increases with the volume.
Reconcile means to take
Or the
two
surface
parties that
area.
are at odds and bring them into agreement. Okay? In the case of answers, why would there be a problem? Because one of them got 15 and one of them got 30. And those are not the same thing in every reference frame. Those are easy agreed upon between reference frames. And the reason is, in this reference frame, you use 5 joule nose lasers in past reference frame. Whereas here, you use 5 joule nose lasers in your reference frame. And energy is relative. So if you transform, in fact, you discover that these nose lasers have an energy of 10 in this reference frame, making it work perfectly. And like, yeah, so in fact, you could have, someone did, you could have gotten part F without getting any of the rest right. Someone did that, and that was cool. What? Might have been. Might have been. Oh yeah, actually. Yeah, no, actually it was Dave, because I have this right here. Okay, number 6, the apple pie. So, we talked about this at length in class. Yeah.
I remember that.
So, I thought I was pretty generous with this one. I gave you pretty good credit if you said circumference changes, therefore the volume changes. And if you remember, the circumference gets larger, therefore the volume gets larger. And I give you credit for that. But that is still a calculation, and as some of you pointed out, equations that you use to calculate things are now suspect, right? You can't just believe that it's going to be pi r squared h or something, right? And so, the way to do it is with a physical argument. I'm not sure if anyone got the complete full credit on it, but some people are very close. I mean, there are definitely exceptions. But I needed a physical argument for why it happened, and the easiest physical argument,
Draw a picture.
Okay, is that you imagine filling the pie with things. And some of you got the idea of filling the pie with things, but it really makes a difference what things you use to make it easier to argue. The best things to fill the pie with would be shaped like pie slices. You fill it with pie slices of a known volume, and you see how many of those pie slices. Why pie slices? Because they have the nice property, they will contract in this direction, right? Because they're moved, that's the direction of motion, they will not contract in this direction. So you can see, these pie slices become skinnier. I will need to put more pie slices into it. Therefore, the volume will increase. I think some people said pie slices, but like that's something else up. And some people got the idea of filling it and used beads or something. What was that beads?
How did I get the right
Yeah, like filling an apple pie full of beads.
How did you get the answer? Because you were using the
Okay, and I thought the credit I gave was reasonably fair on that point. Okay, so that's where we were. Now, let me tell you where we are going. I am going to guess that most of you are not happy with your grades. This is okay, I understand that. And I think it would be unfair to overly base your final semester grade on this one assessment, which has all sorts of extra factors that have really nothing to do with your intelligence or your knowledge of physics, but all those extra stress factors and stuff that are in there, right? So here's my, but at the same time, I have to do this to a large degree because otherwise people copy, I think, at a good individual assessment. So here's my solution. I don't like to give away points for free. I think that's silly. You should have to earn points. But I can at least make them, so I can make you earn points for a good reason. So, let me give you now a good reason.
This is a pop quiz.
It's not a quiz. Everyone take one. I'm sorry,
I don't know what the quiz are.
I don't know.
I would be sad. Look at how blank the
I
page
don't need
is,
a
but how many words there
I
is.
never say that word in class.
Right number of people.
So, what's the definition of what's
Go ahead and take one of these and put your name on it. It'll be important because you don't want to get those together. Yeah. And here's what we're going to do. Here is a physics problem.
Okay.
If we get this question right, do we get a 100 on the test?
It is a Lorentz transformation problem because that was where people had the most trouble. And it is hard. If you look at the persons next to you, you might notice something.
Probably different.
They're not the same. They're very similar. You have different numbers. So
Yeah, we just have slightly different numbers.
here's what I want. They're similar, but they have different numbers. Okay, so that's okay. You are going to take this problem, not right now. You are going to take this problem and then solve it. You are welcome to use any resources you'd like. Let's put it that slightly. Please don't go bothering like physicists at Fermilab. Because the reason is if you have not been teaching this class, you'll have a lot of trouble solving this problem. You have to be like in the middle of Lorentz transformations because it's a pretty tricky problem. Okay, so bugging external people is really kind of unfair to them. So let's not do that. Well, there's 45 people in this class, and Dane's fine. 45 people in this class to work with, right? So you are allowed, you are encouraged to work with others, to look stuff off the internet, use your calculator, make sure you got it right. Okay? The reason I changed the numbers was because that makes it impossible for anyone to outright copy one another, and that was my goal. But you are absolutely welcome to look at other people's stuff and change it. Let's say, how did you do this? And say, what did you do? I don't understand. And I want you to do is understand how to do this problem. It's a tricky Lorentz transformation problem. Wait a minute. Alvin's not here. Someone have an extra?
We have one.
There you go. I gave you the rest of it. Alvin's not here. Tell Alvin he's welcome to come by and look at this test another time. If you want to look at it. Okay. So, when do you guys want this due?
Tomorrow.
3 months.
Right?
3 months.
That's good.
3 months.
I have to give you time, but I don't want to push it to the next unit too much. You know what I mean? So, what do you guys think is a good day?
Friday.
Thursday?
3 months.
Not well,
Friday.
You want
After
2 weekends? By then we're hitting the next quiz, you know. Like the next quiz might be Monday. Next Friday? Okay, you guys said it. No, I mean, it's not like it's a weird thing. It's just, you will have a double up on that day, right? That day is still at homework.
Okay. Oh.
Okay, just so you know, right?
Are we getting?
It's going to happen that way, so, yeah. Okay, next Friday it is. Okay, here's what I want. I want it in paper, okay? You're welcome to do, I recommend you do some work by yourself. Write it up and then give me a neat write-up. But I need this form because it says that letter of which test form it is. That's so I can check your answer. Okay? So I expect a full write-up. I don't need a full write-up. Same as you do the test, nothing crazy, right? But I want an actual write-up from everyone. If you just give me an answer, I'm not buying it.
Can I write up the income
Don't do it.
I'm trying to learn what to calculate it.
I don't know. It's not going to be
Okay, that's like
you'll find it's easy to just do. Okay, does that make sense? Does everyone understand what the assignment is? Okay, can I ask you then to put it away
I'm
right now?
printing at this.
I am sorry this took so much time. I thought you would want to go over the test though.
Yes.
Just to see what happens, see if you missed any of those questions.
oh no, that's not me.
I need this test back. Okay. The rest of this time, I want to work on the projects. I have now up on Moodle a program that will take that detectors.txt file. Remember I told you that? You try to paste stuff into it. It will take it and visualize it for you. Also, time to do a rough cost estimate. I'm still fixing the cost estimate. I'll put up an updated version soon and let you know. But the basics should work. It should work. I tested it on a computer. It ran. So hopefully it still works. For some reason, even though it's supposed to be cross-platform, it doesn't let me do a Mac file. I'm not sure why. But you only need one person in your group to have this thing, so I feel like that should be fine, right? The person who's in charge of the spreadsheet should probably be the one to download this and run it, but it really could be any of you. Okay, so you can take care of that. That's on Moodle. You just unzip it and then run the executable. And then there's a detectors.txt file already there. You can just replace it with your own whenever you want to. I am going to make some improvements over it, hopefully tonight, if I can stay awake, then we'll get that out to you. Good question?
Does that run with R?
Does that run with R?
R groups.
Yours, I will work in a way to add that in. In the meantime, you